This content is produced by Pass the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials, so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. An appliance is not truly serviceable just because the installer managed to place it in the attic, crawl space, or roof location. The complete route has to work. A person must be able to enter, move to the equipment, see the path, stand or kneel at the correct side, use service power, and eventually remove the largest component. I want that idea to stay at the center of this lesson. Access is a chain, and one bad link can make the entire installation fail inspection or require expensive rework. Suppose a crew gets a horizontal furnace into an attic before the ceiling is closed. The unit fits between the framing, the ductwork connects, and the job looks nearly finished. Then the access opening is framed afterward as a standard scuttle. Months or years later, the largest service component cannot pass through that opening. The appliance may operate, but the service route was never coordinated. That is the kind of general B problem I want you to catch before finish work hides it. The first distinction is between general attic access and appliance access. For a qualifying attic, the California Residential Code establishes a general access opening of at least 22 inches by 30 inches. That general rule applies when the attic has at least 30 inches of vertical height over an area of at least 30 square feet. When the opening is in a ceiling, there must also be at least 30 inches of unobstructed headroom above one side of the opening, measured from the bottom of the ceiling framing. Those numbers describe the baseline building access. Once an appliance is located in the attic or underfloor space, the California Mechanical Code adds a more practical test. The opening and passageway must be at least 22 inches by 30 inches or large enough for the largest component of the appliance, whichever is greater. The phrase, whichever is greater, matters more than the memorized minimum. 22 by 30 is not a universal answer that excuses the contractor from checking the actual equipment. If the largest component needs a larger, clear opening for removal or replacement, the opening has to be larger. I would verify that before the framer closes the access, before the mechanical installer blocks the route, and before drywall turns a simple correction into demolition. I put the key dimensions into one reference table. Read it as a journey. 22 by 30 is the baseline opening. 30 inches of headroom matters above a ceiling access. 24 inches is the solid path. 30 by 30 is the work area at the service side. 20 feet is the special travel limit when the passageway headroom is less than 6 feet. The largest component rule can override the baseline opening size. Imagine a replacement air handler with one cabinet section that cannot clear the framed opening. The wrong response is to assume the technician can dismantle a factory assembly in any manner necessary. The general B response is to stop and confirm the manufacturer's permitted service procedure, the actual removal dimension, and the framing solution. The source-backed rule here is not that every unit must be disassembled. It is that the opening must accommodate the largest component. After the opening, look at the route. When the attic or underfloor passageway has less than 6 feet of headroom, the distance from the access opening to the appliance cannot exceed 20 feet. That distance is measured along the center line of the passageway. This is commonly overgeneralized. The rule does not say every attic appliance must always be within 20 feet of the hatch. The 20-foot limit is tied to a low-clearance passageway. When the headroom condition changes, do not automatically carry that same limit into a different situation. I would check the actual geometry and the applicable code, not rely on a half-remembered shortcut. The passageway also needs continuous solid flooring at least 24 inches wide from the entrance opening to the appliance. Continuous and solid are the important words. A few loose boards laid across ceiling joists do not become a compliant service route, merely because a careful person might cross them. The floor must form a real path, and the path must remain usable. That means coordination does not end when the carpenter installs the catwalk. A duct, pipe, cable bundle, brace, storage platform or framed obstruction can take away the access that originally existed. The general B contractor has to protect the path through later rough work. A route that is 24 inches wide on the framing plan but blocked by a large duct in the field is not an unobstructed route. Suppose the mechanical crew lays an insulated duct directly across the catwalk because it is the shortest run. The duct may fit and the air system may even perform, but the service passage no longer functions as intended. The practical correction is to coordinate an approved reroute or another compliant solution without damaging the structure or the duct. I would never treat climbing over fragile ductwork as the plan. At the appliance, the route must end at the correct place. A level working platform at least 30 inches deep and 30 inches wide is required in front of the service side of the appliance. The service side is not whichever side happens to face the catwalk. It is the side where the controls, access panels, filters, burners, blower components, or other service points must be reached. The equipment layout and the platform layout have to agree. A beautiful platform behind a solid cabinet wall does not provide service clearance. The practical effect of the platform is straightforward. It gives the technician a defined, level area to kneel, place tools, open panels, and handle components. I do not need to invent a dramatic explanation for that. The code gives the minimum, and the field condition tells you whether the service side is actually usable. I would verify the platform before the equipment is permanently connected. Once gas piping, condensate piping, electrical raceways, duct transitions, seismic restraints, and insulation surround the unit. Moving the platform or rotating the appliance can affect several trades. Early coordination is cheaper than late correction. A useful field question is this: can a technician arrive on the solid path, step onto a level 30 by 30 platform, open the required service panel, and remove the expected component without stepping off the platform or cutting another trade's work? That question does not replace the code or manufacturer instructions, but it exposes coordination failures quickly. The route also has to be visible and supplied with service power. The California Mechanical Code requires a permanent 120-volt receptacle and a lighting fixture near the appliance. The switch for that light belongs immediately at the passageway access opening. The switch location is easy to miss because an electrician may naturally place a switch near the equipment. That may be convenient after someone reaches the unit, but it does not satisfy the stated access location requirement. The worker should be able to operate the light at the entrance before moving through the concealed space. The California Electrical Code adds the servicing receptacle requirement. A 125-volt, single-phase, 15 or 20 ampere receptacle must be within 25 feet of heating, air conditioning, and refrigeration equipment, and it must be on the same level as the equipment. You will notice that the mechanical language refers to a 120-volt receptacle, while the electrical language describes a 125-volt rated receptacle. I would not turn that wording difference into a guessing game. For coordination, the installation has to satisfy the applicable mechanical and electrical requirements, including proximity, level, and power source conditions. The same level condition matters. An outlet that is physically close but located on another floor or level does not satisfy the servicing rule described in the research. An extension cord does not change the required location of the permanent receptacle. The servicing receptacle also cannot be connected to the load side of the equipment disconnecting means. The practical electrical effect is simple. When the equipment disconnect is open, power to the appliance can be removed without automatically taking away the required service receptacle. If the outlet were fed from the load side, opening the disconnect would also de-energize that outlet. The checklist on screen separates the light and receptacle decisions. The light fixture is permanent and near the appliance. Its switch is immediately at the access opening. The servicing receptacle is within 25 feet on the same level, and not on the load side of the equipment disconnect. These are different checks, even when one coordinated installation satisfies more than one requirement. I want you to hear one more distinction. Near the appliance and within 25 feet are not interchangeable phrases. The mechanical and electrical provisions use different wording. A general B contractor should avoid casually merging them into a single made-up distance. Verify the actual installation against the applicable provisions and approved documents. This topic is really a trade coordination lesson wearing an HVAC label. The framer creates the opening passage, and platform. The mechanical contractor sets the unit and determines the service side and component removal needs. The electrician provides lighting, the entrance switch, and the servicing receptacle. The General B contractor has to make those separate scopes meet in one usable route. I use a simple supervision sequence. First, confirm the equipment location and the actual service side. Second, confirm the largest component that may need to pass through the access. Third, lay out the opening, solid passage, and working platform without altering engineered framing. Fourth, reserve the route so ducts, pipes, braces, and wiring do not block it. Fifth, coordinate lighting, switching, and service power. Finally, inspect the complete route before concealment and again after the surrounding trades finish. That sequence is not a substitute for plans, manufacturer instructions, or the authority having jurisdiction. It is a practical way to find collisions while they are still cheap to correct. Consider a hypothetical attic installation. The access opening meets the minimum dimension. The catwalk is solid and wide enough. The platform is level. Then, a return duct is installed over the center of the path, and the electrician places the light switch next to the furnace rather than at the hatch. Nothing about the original framing dimensions changed, but the finished access system now has two separate defects. A final check must follow the route as it actually exists, not as each trade remembers leaving it. This is also an estimating issue, a bid that includes only the appliance and ductwork, but ignores framing, platform construction, lighting, receptacle work, structural review, roof guards, or access enlargement, can miss real scope. The exact cost depends on the project, but the coordination categories can be identified before work begins. Engineered trusses create a hard boundary. Truss members cannot be cut, notched, drilled, or spliced to make room for an access opening, walkway, duct, or appliance without written approval and concurrence from a registered design professional. I want to be precise here. The rule is not that a field crew may make the cut and then add a 2x4 block that looks strong. The rule requires the appropriate written professional approval before the engineered truss is altered. A truss is an engineered system, so an unauthorized field modification cannot be treated like ordinary non-structural trimming. Suppose the planned 22x30 opening lands directly under a truss web. The wrong move is to cut first because the opening is code required. Two requirements do not cancel each other. The access must be provided and the structure must remain approved. The General B contractor has to coordinate a revised location, an engineered repair or modification, or another approved solution. The decision matrix shows the stop points. If the largest component does not fit, enlarge or redesign the access. If a low passage exceeds 20 feet, revise the equipment or access arrangement. If the path is blocked, restore a continuous, unobstructed route. If engineered truss work is affected, stop for written, design professional approval. If roof edge or roof slope conditions trigger protection, provide the required platform or guard. The shared principle is sequencing. Access is easiest to build before finishes, but it must be checked after every trade that can take it away. I would treat the access route as protected project space, much like required electrical working space. It cannot become leftover space after everyone else finishes. Roof-mounted appliances add slope and edge conditions. When an appliance requiring service is on a roof with a slope of 4 units vertical and 12 units horizontal, or 33%, or greater, a level platform at least 30 inches by 30 inches is required at the service side. A separate edge condition applies when the appliance is within 6 feet of a roof edge or a similar hazard. Guards or rigidly fixed rails at least 42 inches high are required on the exposed side under the mechanical code provision identified in the research. Do not mix those two triggers. Roof slope addresses the need for a level service platform. Proximity to the edge addresses the guard or rail condition. A roof can be relatively flat and still place the appliance dangerously close to an unprotected edge. A steep roof can trigger the level platform even when the unit is farther from the edge. One project may trigger one condition, both conditions, or neither, depending on the actual layout. Imagine a rooftop unit placed 4 feet from an open edge to preserve an architectural sightline. The unit needs routine service and the edge has no parapet or guard. The visual preference does not erase the clearance condition. The contractor has to coordinate the required protection before treating the equipment placement as complete. Roof work can also bring separate occupational safety requirements into play. I would verify the current project-specific requirements rather than assuming that one mechanical code dimension covers every worker access condition. Now I want to walk the full route once, the same way I would inspect it in the field. Start at the opening. Is the qualifying attic provided with the required general access? If any appliance is present, is the opening at least 22 by 30 and large enough for the largest component? If the opening is in the ceiling, is the required headroom available above one side? Reach for the switch before entering. Is the lighting permanent and is the switch immediately at the access opening? Follow the path. If headroom is less than 6 feet, is the center line distance no more than 20 feet? Is the flooring continuous, solid, and at least 24 inches wide? Is the route still unobstructed after ducts, pipes, wiring, braces, and insulation are installed? Arrive at the appliance. Is there a level 30 by 30 platform at the actual service side? Can the service panel open? Can expected components be handled without stepping into an unsupported area? Check service power. Is the required receptacle within 25 feet and on the same level? Is it supplied so that it is not on the load side of the equipment disconnect? Look at structure. Was any engineered truss member cut, drilled, notched, or spliced? If so, where is the required written approval and concurrence from the registered design professional? For roof equipment, check slope and edge distance separately. Does the roof slope trigger the level service platform? Does the appliance location near an edge trigger a guard or rigid rail? The memory line is compact. 22 by 30 gets you through, unless the largest component needs more. 24 inches carries you to the unit. 30 by 30 gives you the work area. 20 feet applies when the passageway is under 6 feet high. 25 feet controls the servicing receptacle, and that receptacle stays off the load side of the disconnect. The light switch waits at the entrance. This is a testable concept based on the published CSLB study outline because it sits at the intersection of HVAC, framing, electrical coordination, inspection readiness, and safety. The point is not to memorize isolated numbers and forget the job. The point is to see one complete service route and know which trade owns each part. There is an audio practice quiz for this specific episode. It is audio-based, with each question read aloud and each answer selected by tapping, because I know many people are studying while driving, working, or otherwise on the go. Go to the description below this video. You will see a link that says, Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about appliance access or service clearances. Subscribe so I can help you stay on track through every episode until you get your license. I am rooting for you, and I want the time you spend studying to turn into confident field judgment.